Hi everyone. So, as you see, ISRO previous year questions on induction machine. We are, looking at these previous year questions on network analysis subject wise. We're looking at, you can check the description for playlist, detailed playlist for network analysis for machines, DC machines, synchronous machines, transformers. All three are over. Now we're on to induction machines. Okay. So let's see how nicely you're going to solve these questions. You'll have to solve the question. Okay. I'll pop the questions. You'll have to solve those. Are you guys ready? Give it a thumbs up quickly so that we'll start with the first question. Okay. I'm heading into the first question without wasting much of time. Bang. There you go. This is the first question and a simple one. Let's see who is going to answer correctly. 2 minutes is, pretty big for this question. But yeah, 2 minutes timer is running. Quickly answer it. Nice. We're already getting the answers. We're already getting the answers. Good, good. Very good.
The first step towards achieving your dreams is having the right coach.
That's
Get the best
really nice to
education
see.
with PiSquare
And
Academy
everybody's saying
and
A.
make your gate
So
electrical
answer
dreams
must be
come
A.
true. Download the app
Good.
now.
So let me just quickly explain because already you got the answer. So I think it's better I'll explain now because most of you answered it correctly. Everyone answered correctly rather. The starting torque of a slip ring induction motor can be increased by starting torque is proportional to resistance, rotor resistance to be more precise. And this rotor resistance will not affect the maximum torque. It only affects the starting torque. Okay. So if you want more starting torque, you'll add more resistance in the rotor. Even that's the beauty of slip ring induction machine. If it is a squirrel cage induction machine, you will not have this facility to add the rotor resistance. Hence, we'll call squirrel cage induction motor is not having such a good starting torque. I mean, starting performance is poor for squirrel cage, but running performance is good for squirrel cage. In Bark also, these were the questions. What is a double cage induction motor? What is double cage induction motor? It is to improve the starting performance of the induction cage rotor or squirrel cage rotor. Okay. Anyways, to answer this question, starting torque is proportional to R2. So higher the rotor resistance, higher the starting torque. Starting torque only. Okay. Starting torque means torque when speed is equal to 0. So adding more external resistance to the rotor will give more starting torque. That's possible only for slip ring machine, not for squirrel cage machine. Okay. Shall we go to the next one? And it's good that everyone answered correctly. Everyone answered correctly. Okay. So that's good. Let's get to the next question. Yeah. Try this. Try this one. This is also a simple one. Okay. Try.
The first step towards achieving your dreams is having the right coach. Get the best education with PiSquare Academy and make your gate electrical dreams come true. Download the app now.
Anyways, I think for this also 2 minutes is, it's pretty big time for this. So let me explain this question as well. See, now you don't have to run after the calculator to solve these questions. This is one of the popular questions. Okay, what is the popularity in this? For electrical engineer, if someone asks you for a four-pole machine, 50 hertz frequency, what is the synchronous speed? Let me just write here. 4-pole machine, 50 hertz, synchronous speed is 1500. Without calculator, you should be able to write this, because most of the cases you will see, and we're in India, 50 hertz, obviously, and 4-pole machine is the one which normally gives. They will give 4-pole machine. So 120 F by P, if you do that, Ns is equal to 120 F by P. If you just do that, you will get obviously 1500 RPM. Okay, so these three are wrong answers. You don't know what is RPS. RPS means what? Revolutions per second. Okay, RPM means revolutions per minute. So as these RPMs are wrong, obviously this RPM must be right. Okay, you don't have to calculate. You don't have to be after calculator. Or else if you want to calculate in RPS, 1500 by 60, that's going to give you RPS. Okay, so it should be giving you 25 RPS. Yes, you guys have answered correctly. Prashant is asking, is PiSquare is providing power system courses? Power system courses, yes, we'll be launching. It's getting done. Power system is happening. We will launch according to the schedule, full in the complete gate package. Power systems also there. So you will get it shortly. Let's move to the next question. And meanwhile, if you want to be good at power systems, definitely CL Wadhwa questions are very much useful. Okay, and in PiSquare app, you have CL Wadhwa questions with a detailed explanation. If you just go through that package, that test series, then it will help you a lot in power systems. Okay, because normally you will not get these power system CL Wadhwa solutions anywhere. Answers you will know, but solutions hard to get. Okay, so that you will get it in the app. Just download the app, you'll get all the details. Let me just move to the next question. Okay, next question on the screen. You got 2 minutes time. Let's see. Hi Vinay, hi 1000. These also just 30 seconds question maybe. Okay, yeah, CL Wadhwa, you can download it. With the detailed explanation, you will get CL Wadhwa things.
The first step towards achieving your dreams is having the right coach. Get the best education with PiSquare Academy and make your gate electrical dreams come true. Download the app now.
Okay, this is a simple one, simple question. So 2 minutes is not required for this question. Okay, these are all ISRO previous year questions. Of course, some interesting questions also there. It's not that all questions are easy. You can see, in the previous lectures, there I have given what question is having good analysis, all these things, the tags, bookmarks are given for the previous questions. Okay, check the link in the description, you will get everything. Yeah, coming to this. A 3-phase slip ring induction motor is fed from, see, this question is asked in recent BARC interview. One of our student, has called me and said, sir, I got this question and I answered it properly. I mean, there are many questions. Out of those questions, this is one of the questions. Okay, so they asked in an interview. Okay, now we are getting this in ISRO 2013, but it could be one of your interview question also because it has some interesting analysis. Let's see what is that analysis. Okay, a three-phase slip ring induction motor is fed from the rotor side. Normally, we will give input to the stator, but it is said we are feeding input to the rotor side, not to the stator side. Okay, so it must be a slip ring induction motor because squirrel cage induction motor, it's not possible to give supply to the rotor. Okay, and stator winding is short circuited. Normally, we short circuit the rotor and will give input to the stator. It is reversed now. Roles are reversed. Okay, roles are reversed. So this is a really an interesting question. Okay, give it a thumbs up for the question. For the question, give it a thumbs up. And yeah, now it is said. See, this I explained the question in this part. Nothing much. Now comes the frequency of the current flowing in the short-circuited stator. In the stator, EMF will induce mutual induction due to mutual induction. Now, what is the frequency? What is the frequency in which stator winding it's carrying? The EMF induced frequency. Don't think too much. Whatever the analysis you're doing for a regular case, same analysis is here also. Means if you are giving input to the stator, then what is the frequency of the rotor EMF? Slip times of input frequency, right? Rotor frequency is regular case I'm talking about. Slip times of stator frequency. Here also same. Here also same. But here stator frequency is equal to slip times of rotor frequency. Okay. So it is slip frequency. You'll call it as a slip frequency. Of course, in the interview, back interview, it was not asked for what is the frequency and all. It is asked for complete analysis. Explain this, its operation, how it's going to work. Okay. So the operation is when you give supply to the rotor, stator should rotate. Careful. Stator should rotate. But stator is fixed, stationary. Why stator should rotate? Because of the induction principle and Lenz's law. The relative speed between magnetic field, rotating magnetic field, and the stator should be less. I repeat, rotating magnetic field and stator relative speed must be less. To reduce the relative speed, that's what Lenz's law. Stator should rotate, but stator is fixed. But relative speed has to reduce. That's Lenz's law. So what we'll do is rotor will start rotating. You are giving supply to the rotor and the rotor will start rotating. Okay. Now, in case of normal induction motor, if the rotor direction, normal case, I'm talking about normal case. If I take a normal case, okay, the normal case is suppose RMF is this way, rotating magnetic field direction is this way. So NR, rotor will also rotate in this direction. This is rotor. Okay, this is rotor. Rotor will also rotate in the same direction. But this specific case, rotor will rotate in opposite direction. Okay, not in the direction of RMF, rather it will rotate opposite to the direction of RMF. Okay, if RMF is clockwise, rotor will rotate anti-clockwise. Okay, that's what important aspect. Anyways, these are all discussed in case of our induction machines lecture. Okay, induction machines course, it is clearly explained. Now let's go to the next question. Yep, answer this. Raju is saying, what if rotor winding is delta connection? Okay, I'll come to that, Raju. Don't think that there's much of mathematical, equations and all. No, it's simple one, simple to handle. You don't have to use calculator also.
The
Okay,
first step
simply you can
towards
handle it.
achieving your dreams is having the right coach. Get the best education with PiSquare Academy and make your gate electrical dreams come true. Download the app now.
We got the answer already from Raju. These are all almost 1 minute questions. Okay, not much time is required for these questions. Okay, and Sampath, he is even saying an explanation. Explanation also I think he has given. Let's see what's the question is asked. When the supply voltage to an induction motor is reduced by 10%, maximum torque is decreased by approximately how much percent? Beat starting torque, beat maximum torque, they are proportional to input voltage square. Okay. Here, suppose input voltage has become half, then these two torques will become 4 times less. Okay. So because they are proportional to input voltage square. Remaining everything is if it is constant. Okay. Okay. Now it is said voltage is reduced by 10%. Careful, careful. Voltage reduced by 10% means earlier it was 100%. Now it become 90%. Whenever it is said, whenever in the questions, you'll get different kind of questions based on this percentage reduction, percentage increase, especially when you're dealing with speed control. Okay. At that time, you give that percentage values. Earlier it was 100%, now it is 90%. In that case, what is happening to the maximum torque or maybe starting torque? They will reduce by input square times. So earlier this was torque was 100 into 100, it is 10,000. 10,000, let's say 10,000 Newton meter for the sake of simplicity. Okay, 10,000 Newton meter is huge torque, but yeah, for the sake of simplicity, I'm taking this. And 90 square is 8100. Okay, so if I take this one as 100%, if I take this one as 100%, then this will be how much? This will be 81%. So when voltage was 100%, torque is 100%. When voltage reduced to 90%, torque has reduced to 81%. So the reduction in torque is 19% reduction in the torque. For the 10% reduction in the voltage, 19% reduction in the torque is happening approximately. Okay. So approximately it is 19 is not given, so 20 is answer. Okay. Very good, Raju. Now coming to Raju's question, Raju is saying if rotor is having a delta connection, see how does it matter if it is star connection or delta connection? You're talking about the previous question where you are giving input to the rotor. You are giving input to the rotor, be it a star, be it a delta, how does it matter? Okay. But normally, slip ring induction motor means it will be a star connection, not delta connection. Why? The purpose of having the slip ring induction motor itself is to have a facility to add some internal resistance. If it is delta connection, you can't really add some internal resistance. Only for star connection you can add some external resistance, not internal, external resistance you can add so that you can control the starting torque. Okay, so usually the rotor is of star connection if we talk about the slip ring. But yeah, in the previous question case, be it a star connection or delta connection, you can give the input voltage anyways, right? That doesn't really matter. I hope question you got the answer for the question, dear Raju. Let me move to the next question. Yeah, try this.
The first step towards achieving your dreams is having the right coach. Get the best education with PiSquare Academy and make your gate electrical dreams come true. Download the app now.
This question is really interesting question. Of course, it's not difficult, but the question is interesting. Try. I think you may have to have a calculator in front of you, maybe. Try it. A little bit of math, not much. A little bit of math is required. So if you have a calculator handy, it would help you greatly. Okay, try it. Try it with the calculator. See, if you don't have a calculator, at least give me the formula. What kind of formula you should use? What should be the concept to apply for this question? If you don't have a calculator, at least give me that. Okay. Raju, just maybe you're missing something, I think. Just look at the question and try to answer again. Look at the question once, Raju.
The first step towards achieving your dreams is having the right
just
coach.
look at the question once.
Get the
What
best
is asked?
education with PiSquare Academy.
It is asked for
and make your
increase,
electrical
percentage
dreams come
increase.
true.
How
Download
much is
the
the
app
increase?
now.
Okay. Change in percentage change in the copper losses. Okay. Anyways, time's up. Time's up. Your time is running, right? So time's up. Let's get to the question. A three-phase induction motor is driving a full load torque. Full load torque it is driving, and the torque is independent of speed, because it is saying the load torque is constant. That's what he is trying to say. In this line, which is independent of speed, means what? The load torque is a constant load torque. At all speeds, you'll have same load torque, constant load torque. Now, in that case, if voltage drops to 90%, means just, we have seen earlier 100% to 90%. Okay. Then we have seen effect was torque reduces by 80, reduces to 81%, means reduced by 19%. Anyways, the percentage increase in the motor copper losses. Oh no. It is not something about copper losses. In copper losses, what is the percentage change? It's easy, not difficult. We know copper losses formula. There is one powerful relation. You have to keep that relation in your mind. 3 powers in terms of slips. We'll write that. What's that? Pg is to Pcu is to P mechanical is 1 is to S is to 1 minus S. This is very powerful equation. Okay. Anyways, for this, copper losses is equal to slip times of Pg, where Pg is input to the rotor. Input to the rotor. Now, I can say from this, copper losses are proportional to slip. Copper losses are proportional to slip. So, now I have to see if input voltage is reduced to 90%, what is the change in slip? That's what you need to find. Okay, you need to find that. How do you find that? We have a lovely relation. When constant load is there, when load torque is constant, then only you'll be using this. Under that case, slip and input voltage square, this will be constant. Okay, this will not change. Product of slip and input voltage square will be constant. Okay, I mean to say, in the first case, let's take it as SA and V1A, when 100% was there. When input voltage is 100%, this is the slip and this is the input voltage, product of these two. Once it becomes 90%, input voltage become 90%, then also you should be having same value. This must be same. The product must be same. The product must be same. Okay. Means, I'm just erasing this. Means SB is equal to, write this, SB is equal to SA into V1A by V1B whole square. Okay. Which means I'm writing this one as SA into Am I done right? Yeah, I done right. 100 by 90 whole square. 100 by 90 whole square. So SA into 100 by 90 whole square. Tell me how much is that? 100 by 90 whole square will give you 100 by 90 whole square will give you 1.23 times of SA. Means just simplifying this, you'll be getting SB is equal to this 1.23 times of SA. Which means what? The new slip. What is this? SB means what? SB is a new slip after the change has increased by 23%. Okay. It is increased to 123%. Means it is increased by 23%. So as slip is increased by 23%, copper losses will also increase by 23%. So increase in copper losses is plus 23. Am I clear? Am I clear? Give it a thumbs up if I'm clear. Give it a thumbs up if I'm clear. Am I clear? Good. Good to see that. Next question. Are you ready for the next question? Meanwhile, we got a question here. Sampath is asking something which is having more dielectric strength, sir. Transformer oil or silicon mineral oil? Transformer oil, do you know what is the oil used in transformer? The oil itself is silicon mineral oil is used in transformers. So transformer oil itself is a silicon mineral oil. Okay, there is nothing special called transformer oil. Okay, so both are same. Good. We got a confirmation from Dinesh. Let me just go to the next question. Now question could be, sir, which one will have more dielectric strength? Air is having more dielectric strength or transformer oil is having more dielectric strength? That could be an interesting question. Okay, check it out. You'll get something interesting answer also. There, in case of a transformer, oil is used for cooling purpose also, not just only insulation. Mainly rather, I would say cooling is a key aspect there, alongside the insulation also. Okay. Anyways, that could be an interesting question. Air versus transformer oil, which one is having good dielectric strength? Because this was one of a BARC interview
The first step
questions.
towards achieving your dreams is having the right coach. Get the best education with PiSquare Academy and make your gate electrical dreams come true. Download the app now.
Raju, just check it once. Check it once. Question, read the question and check the option what you opted for. Dinesh, good. And the 3 is good. You got some nice answers.
The first step towards achieving your dreams is having
Okay,
the
I
right
think you're having some issues maybe with this question, with the rotor injection method. There is a special motor for this. You cannot inject the EMF into the rotor for a normal motor. It has a special setup altogether, and there is a special motor. Some people will call it as a shaggy motor or S-charge motor. Okay, I don't know how many of you have seen that, at least the motor. Most of the people even don't even see that motor. Okay, it's a special kind of construction, and it has a commutator. Okay, it is having a commutator. Yes, it is an AC motor, induction motor, but yes, it has a commutator. Anyways, now why do we use this? EMF injection method is used for the speed control purpose. Even, based on this concept of EMF induction, wind turbines are developed based on the concept what is involved here. Okay, and those turbines, of course, they will not have these commutator, all this bullshit stuff. Rather, they're having a power electronic setup to induce EMF or inject EMF into the rotor. That motor altogether is called as double fed induction motor. Okay, what's that? Double fed induction motor. Anyways, I'm just giving information. That's the advancement of this EMF injection method. So basically, this EMF injection method is used for speed control technique. Okay, if you want to increase the speed of the rotor, then you will inject the EMF in the same phase of, same phase means what? Same phase of the rotor EMF. The rotor EMF is having some phase angle. In the same direction, you will inject the new EMF, extra EMF, foreign EMF into that. So that net EMF is more, then you can increase the speed of the motor. If you inject the foreign EMF in opposite to the existing rotor EMF, then the speed of the rotor will be reduced. Okay. So here opposite and same phase for the speed control. But whether it is opposite or in phase, it has to be with the same frequency as the slip frequency. You should inject the EMF, maybe in phase, maybe opposite. That depends on the application, what you want. But in both the cases, it should be same as rotor frequency. And rotor frequency is same as slip frequency. So you should inject the EMF with slip frequency. That's what the challenging thing here, because slip keeps on changing. Slip is not a constant, right? Slip changes with respect to speed. Little change in speed will change the slip, will change the slip frequency. Hence, you should change the input or injected frequency also. Very critical and very interesting phenomena here. If you see the concept, the construction behind that, it will be amazing. Okay, if you get a chance to see, experience it once, that motor, as charge motor or shaggy motor or whatever you call. Sir, if you use VVVF drive, it acts as a starter and speed control. Is it right? Yes, absolutely. Absolutely. You can start as well as do speed control. Sir, is it similar to the conditions for parallel operation of a transformer? Which one, dear? Yes, you can say that. Parallel operation of a transformer, but you can say in a way, but both are much different. But yeah, you can say in a way, you can say that. So answer for this is option A. See here, rather than answer, the analysis is pretty much important, because in an interview also you could get these kind of questions.
And make
analysis,
your
focus on the analysis.
Dreams come true.
Anyways,
Download the
moving on
app
to the next.
now.
Simple one. I think you can answer this maybe in 10 seconds. I think 10 seconds without using calculator. You can do that, right? Raju is killing today. He is giving all the answers first. Then we got Datri and Manohar. Nice. We got 3 votes. You can see. Others?
The first step towards achieving your dreams is having the
You
right coach.
participated. Just adding numbers or adding options there, or AI will pick it up, will display. Okay. AI is everywhere. AI is everywhere. Now coming to this simple question. Very simple. What is it? If the full load speed of a 3-phase 50 hertz induction motor is 950 RPM, okay, means can you guess what could be the synchronous speed of this particular machine? Just give it a guess. What could be the synchronous speed of this particular machine? Yes, give it a guess. Number? What's the number? I want to see the number. Good, Raju. We got something from Raju. Others? Manohar, Datri, Dinesh, Sampath. What happened? You guys are not responding. Okay. Answer is 1000 RPM. Why I'm saying 1000 RPM? Careful here. One interesting point I would like to keep. Always, induction motor will run less than synchronous speed, but close to synchronous speed. Okay. So why close to synchronous speed? Because if higher the slip value, then copper losses will be high, efficiency will be less. Okay. So that's why slip value should be low so that efficiency will be high. So the closer value to this 950 is 1000 RPM. If you use 6 number of poles for 50 Hertz, so you'll get 1000 RPM. Anyways, that's a guess. And it is said at full load, it is operating at 950 RPM. The moment you reduce the load, I said half load means load has reduced. Load has reduced to half. You're driving a bike. Suddenly, load sitting behind has reduced. He fell down. She fell down when you're driving. Then suddenly, bike will move faster, a little faster. So speed will increase slightly. Okay. So this is wrong. Yes, speed will increase slightly. Because yes, induction motor is almost a constant speed motor. Okay, if not exactly constant, almost constant. So little change in the speed. So that increases 975. Not, it will not become double. Okay. Anyways, Datri, I think you got it. How you're asking for 1000 maybe? How it is 1000? I think you got a clarity, Datri. Yes. Give it a thumbs up. Those who understood this concept, give it a thumbs up. Shall we go to the next question? Bang.
Academy and make your gate electrical dreams come true. Download the app now. The first step towards achieving your dreams is having the right coach. Get the best education with PiSquare Academy and make your gate electrical dreams come true. Download the app now.
Okay, download the app now. You will get all those things. ISRO previous year question papers, everything you'll get it. Ganguly sir is saying, right? Okay. Yeah. For controlling the speed of induction motor, the frequency of supply is increased. For the purpose of speed control, I'm increasing the speed. I'm increasing the supply frequency by 10%. See, we have developed a lovely tool in the induction machine course. Lovely torque slip characteristics live tool we have developed. That tool will automatically draw for a particular change in frequency what will be the torque slip characteristics. It is drawing live. Okay, from that you will get a cluster clarity on these changes in frequency and all these things. Okay. Yeah. Supply frequency is increased by 10%, and for magnetizing current to remain the same, means I mu must be same, means flux must be same. There is a change in flux, there is a change in I mu. Flux is same, I mu is same. For flux to be same, V by F must be constant. That's what somebody's saying. VF drive. Variable voltage, variable frequency drive. I mean, that's maybe something different. V by F control will call, so that you're changing voltage as well as frequency, but the ratio is maintained constant. Okay, which is one of the popular drives. So that flux is constant, hence IMU is constant. So if there is an increase in frequency by 10%, there has to be increase in voltage by 10%. Okay, but of course, if that increase in voltage goes beyond rated voltage, machine will be damaged. You should be careful that when you're increasing the voltage, you should be careful. You should not let the voltage increase beyond its rated value. Okay, here nothing is mentioned. It is said only, I want the flux to be maintained constant. Then simply change the voltage. Okay, increase the voltage in proportion with the frequency. So supply voltage must be increased by same 10%. Okay, I'm going to end this lecture with this last question. Okay, this is the last question of this session. Answer this, we'll see. Surprised that we didn't get any questions yet. How come? Simple one. Simple, simple, simple. No answers yet. Strange to see. Raju, Dhatri, Manohar, what are you guys up to? Raju has responded finally. It's not that
The first
difficult
step
also.
towards achieving your dreams is having the right coach. Get the best education with PiSquare Academy and make your gate electrical dreams come true. Download the app now.
Okay, let me explain. Okay, you try if you're trying, but let me explain because it's an easy one. It's not going to take much time. If it is not happening for you, means it will not happen. Okay, within 1 minute, if it is not happening, it will not happen for you. I think maybe the speed of an induction motor is, see, whenever you see this speed, when voltage is changing, frequency is changing, for that specific case, you should be able to draw quickly that, torque slip characteristics you should be able to draw. That will help you a lot. Okay, if you're drawing torque slip characteristics. It is said speed of an induction motor is controlled by varying a supply frequency, but V by F is constant. Okay, that's what just I said. Then see, torque slip characteristics when V by F is constant. Okay, this is speed and this is torque. Torque slip characteristics, can you help me in drawing it? Like this, like this. Maximum torque will not change, but the speed at which maximum torque is getting changed and the starting torque changes. Okay, maximum torque values doesn't change. So breakdown torque means what? Breakdown torque is nothing but a maximum torque. Okay, so you have to know these alternative names. They will call it as a stalling torque, breakdown torque, maximum torque. All means the same. Okay, and magnetizing current, what will happen to the magnetizing current? Just now I said, if V by F is constant, magnetizing current will be constant. Okay, breakdown torque, maximum torque is anyways constant. Starting torque is changing. Starting torque is changing with the increase in frequency. This is increase in frequency. Okay, increase in frequency is like this. One frequency is here, higher frequency is here, higher frequency is here, provided V by F is constant. Okay, so starting torque is reduced, but maximum torque is same. Okay, so option is, right answer is A. Okay, so let's see in this session who is the winner. There's some winner also for the sessions. We developed, as I said, AI is there that is taking care of the winner. Okay, let me just uh, show you the winner. I think we have some people. Give me some time. Oops. We are rolling something for you, buddy. Huh. There is some winner. Who is the winner? Come on. Okay. He is a winner. For the winner, please post videos regularly. Yes, we'll be doing it. We'll be doing it. We'll be doing it. Winner should be, you may contact, you may contact us. You may contact us on WhatsApp, or maybe app will give you something for you. Okay, we'll give you the course. Obviously, something means course for the participation, your participation. Okay, so that's it. That's the end of this previous year questions ISRO part 2013 things we have seen. In the next, we'll see 2014. Till then, bye bye. Catch you in the next session. Good time.